Okay, I'm going to go ahead and finish up the last two problems on the notes from yesterday. I just want to make sure that we're really good and clear on these problems. So on number 11, it's giving us the diameter of cylinder A, and it's also giving us the diameter of cylinder B. Okay, because it's using these words diameter, these words are all under the very front of your paper. Linear measurements, these represent your scale factor words, okay? So when it's giving you words like these are all representing scale factor. So let's look on the back. So diameter is one of those scale factor words. So my scale factor is telling me I have to compare 24 to 30. Now I want to make sure that that's in simplest form. So 24 divided by 30, math, enter, enter. And that's going to give me 4 to 5. Now it wants the ratio of the volume. So volume, remember, is cubed. So I have to cube those numbers. 4 to the power of 3 is 64. 5 to the power of 3 is 125. So that's what I was looking for. Okay. And then number 12, we are comparing pyramid A to pyramid B, and it's giving me volume first. So I'm going to take those volumes, I'm going to make sure that they're in simplest form. 648 divided by 1029. Math, enter, enter. And I get 216 to 343. Now I want the surface area. So I have to find scale factor before I can do anything else, like what we were doing previously in these types of problems. So you have to work backwards. Remember, volume is cubed, so this is like A cubed. In order to get rid of the cubed, you have to take the cubed root. So remember, go to math, scroll down to number 4, type in 216, and that gives you 6. And then do it again. Math, scroll down to number 4, type in 343. That gives me 7. So to find surface area, though, I have to square those. 6 squared is 36. 7 squared is 49. And there I have it. Okay, I just wanted to make sure that we were clear on those problems. So if you haven't already finished up number 8, make sure you have that done. Okay, so next problem, ignore the bell. Next page that you have in front of you, or you should, is effects of changing dimension. Okay, so we're going to look at what happens when we change our dimension. When we change one dimension or two dimension, we'll see what happens. Okay, it depends on which dimension we're changing. So it says if the dimensions of a solid are multiplied by a scale factor of A, then the surface area is A squared times the original surface area, and the volume is A cubed times the original volume. Okay, makes sense. So let's go ahead and look at our surface area examples. So these are our A squared examples. Okay, that's our A squared. So number 1 says if the dimensions of a figure are doubled, so doubled means 2, how many times larger will the surface area be? So we're going to take 2 and we're going to square it. So I get 4. So 4 times larger. Okay. So number 2, the surface area is 62 centimeters. The dimensions are multiplied by 5, so we've got to find the new surface area. So since it's multiplied by 5, that's the number we're going to square. It's going to be 25 times larger, so we've got to take 25 times the original surface area to see how much larger it is now. So 62 times 25 is 1,550 centimeters squared. That's the new surface area. Okay. Number number 3, the surface area of the figure is 736 inches squared. The dimensions are multiplied by 1/4, so it's going to get smaller. Let's see how much smaller. I got to take 1/4 and I'm going to square it. 1 squared is 1, 4 squared is 16. So it's going to be 1/16 the size that it was. So the size that it was 736 inches squared. So I've got to multiply by 1/16 to see what it will be. So 736 times 1/16 is 46 inches squared. So it did get smaller because it was a fraction involved. Okay, so number 4, we kind of have to work backwards. So it says cone A is similar to cone B. Cone A has a surface area of 1,422 kilometers squared, and B is 158 kilometers squared. How many times larger is cone A than cone B? So it is talking about surface area. This is area squared, A squared. So let's make a fraction out of these two numbers, 1422 divided by 158. And let's reduce it. Let's divide it. I end up with 9. This right here is A squared. And what I want is A. So to get from A squared just to A, you have to take the square root. Square root of 9 is 3. So I've got 3 times larger. Working backwards there. So now we're going to look at some volume examples. These are A cubed examples. So number 5, how many times larger will the volume be if the dimensions are multiplied by 4? So I'm going to take 4 and I'm going to cube it. Ignore the bell. So 4 cubed is going to end up with 64. 64 times larger. Okay. Number 6, the volume is 110.5. I want to find the new volume if the dimensions are doubled. So 2 to the third is 8. I'm going to take it. It's going to be 8 times larger, but I want to find what the new volume is. So 110.5 times 8. That's going to give me 884 feet cubed. Okay, number 7. The volume is 972 meters cubed. The dimensions are multiplied by 2/3. So I want to take that 2/3 and I want to cube it because we're dealing with volume. So 2 to the power of 3 is 8. 3 to the power of 3 is 27. So this is the fraction that I want to multiply by the volume. So 972 times 8 over 27. It ends up being 288 meters cubed. So number 8, the volume is 21 inches cubed of A, and the volume of solid B is 4,536. So we're going to divide these. I'm going to divide the bigger by the smaller so that I don't end up with a fraction. 4,536 divided by 21. And I know since it would have been a fraction if I divided the smaller by the larger, it would be a fraction. So this figure is going to get smaller. Okay, it tells us it's going to get smaller. So if I divide, I get 216. Now remember that this is A cubed. And to get rid of the cubed, you have to take the cubed root. So in your calculator, you go to Math, scroll down to number 4, and type in 216. And you get 6. So this is what happens when you're changing all of the dimensions involved, okay? But if you flip it over, we're going to see what happens when you only change one of the dimensions, okay? So changing only one dimension means the figures are not similar. Therefore, we need another strategy. In this situation, you're going to choose test values, calculate both the old and the new surface area and volume, and compare our answers. Okay, so this sounds worse than it actually is, but it's really not that bad, I promise. So in number 9, it says how many times larger is the volume, we gotta pay attention, volume of the cylinder if the height is doubled. So we're gonna write down, first of all, the volume formula for a cylinder. The volume formula is pi r squared height. So we're gonna do 2 scenarios here. The first scenario is I'm going to make r and h just 1. I'm going to pick values. These are our test values that we're talking about. I'm going to make the radius 1 and I'm going to make the height 1 because that's the simplest values that I can pick. And then we're going to change it. The height is doubled in the second scenario. The radius is not changed, but the height is doubled. So where it was 1 here, it's going to become 2 here. So all we're going to do is we're going to plug these values in and we're going to compare the volumes that we get. So my volume here, I'm going to take pi times 1 squared times 1. And I'm going to do what it's called leaving it in terms of pi. So pi times 1 squared times 1 means if I leave it in terms of pi, I'm just going to multiply the numbers and I'm not going to multiply pi in my calculator. So 1 squared is 1 times 1 is 1. So all I have left is 1 times pi, which is just pi. Okay, we're going to leave it in terms of pi. And that's how we're going to do all of these problems. We're going to leave them in terms of pi. So for the second scenario, we're going to plug it into the volume formula again. Pi times 1 squared times 2. Only multiplying the numbers. 1 squared is 1. Times 2 is 2. So what I have here is pi times 2, which is 2 pi. So now we're going to compare those. What happened? From here to here, it actually got 2 times larger, okay? So in order to verify that, you divide. Take this figure, divide it by this figure. 2 pi divided by pi. The pi's cancel. So you know that it got 2 times larger. We know it got larger because the problem told us that it was larger. And the values got bigger from case 1 to case 2. So we're going to do a couple more of these. So how many times larger is the volume of a square pyramid if the base edge is tripled? Okay, the volume formula for a square pyramid, it's 1/3 area of the base times the height. Where remember that base for a square pyramid, the base is side squared. Okay. Alright, so basically what I have here, I'm going to replace that area of the base with side squared. So my formula would be volume equals 1/3 side squared times height. Okay? So I'm going to pick the side to be 1 and the height to be 1 in the first scenario. In the second scenario, the base edge, which is one of the sides, is tripled. So the side becomes 3 and the height is still 1. So let's plug in these values. Figure out what our volume would be. So this would be 1/3 times 1 times 1. This would just end up being 1/3. Okay? So now over here, I'm going to plug it in. 1/3 times 3 times 1. If I plug that in, you can plug it into your calculator, 1/3 times 3 times 1. You'll end up with, I'm sorry, I didn't square this. This is supposed to be squared. And this is supposed to be squared. Okay, so if you go ahead and multiply that all in, this is still 1/3 though. If you multiply that in, you end up with 3. So now you're going to take and you're going to divide. Take this value and divide it by this value. 3 divided by 1/3. You can type this in with parentheses down below into your calculator. If you do 3, I'll show you how to type it in. 3 divided by parentheses 1/3. You end up with 9. And this is 9 times larger. Okay. Let's do another one. Number 11, how many times smaller this time is the surface area of a sphere if the radius is multiplied by 1/2? So surface area formula for a sphere is 4 pi r squared. Okay, so we only have one variable here. So I'm going to pick my first radius to just be 1. And then if it's multiplied by 1/2, 1 times 1/2 is just 1/2. So I'm going to plug it in. My surface area here will be 4 pi times 1 squared, which will just be 4 pi if I leave it in terms of pi. So here, my surface area, if I plug that in, I'm going to have 4 pi times 1/2 squared. So first of all, I'm going to figure out what is 4. I'm going to leave out the pi because I don't want to plug it into my calculator, times 1/2 squared, which is just 1. So all I'm left with is 1 pi, or just pi. So I'm going to take the bigger, divide it by the smaller. I know I've been taking this one divided by this one, but in all of the cases I want to take the bigger number and divide it by the smaller number. So I'm going to take 4 pi divided by pi. The pi's cancel. So this figure got 4 times smaller. Okay, so I'm going to give you the formulas for the last two, but I want you to work them. So the surface area formula for a cube is 6 times side squared. You can use that one. And then the volume of a cone is going to be 1/3 pi r squared times height. So I want you to finish up those problems, and then you can start on your homework. Make sure that you are quietly working.